Hello, welcome to the first episode of the Leukopak Lady. I hope you find it helpful and informative. I want to start this series by talking about the different types of cell therapies, at least how I broadly categorize them. And I start here because cell therapy field is so broad, and I realize that we could all be talking about different things and not realize it unless we spell it out from the beginning. So my first category of cell therapies is autologous therapies, obviously. These are the patient-derived therapies. Patient cells are collected and either given back to them after a series of traditional interventions like chemotherapy, or they're engineered and manufactured into CAR therapies, TIL therapies, or MSC therapies before being given back to the patient. And the first engineered autologous cell therapies were FDA approved in 2017. These therapies carry low risk of rejection or graft versus host response because they're derived from the patient's own cells. However, manufacturing costs are very high, and this can significantly reduce patient access. My second category is allogeneic therapies for direct transfusion. These therapies are derived from healthy donor cells, and they're designated for a specific patient. These are typically hematopoietic or blood stem cells collected from peripheral blood or bone marrow. They're minimally processed before being introduced into a patient for a stem cell transplant. These therapies have been around for decades, and before the wave of autologous CAR T therapies were on the scene, this is typically what people meant when they were talking about cell therapies. And although these therapies are carefully matched between the donor and the patient, they carry risks of rejection and graft versus host response. My third category is allogeneic therapies that are engineered. These are the emerging therapies like CAR T, CAR NK, and other types of therapies that are made to treat cancer, autoimmunity, infections in large groups of patients. These are donor-derived, but instead of being designated for a specific patient, the donor material is used to manufacture many doses for many patients. And although many of these therapies are being tested in clinical trials, none are FDA approved yet. They do have great potential to reduce cost and increase patient access, but they also come with the same risks as the therapies for direct transfusion. To avoid rejection or graft versus host response, the therapy dose either needs to be carefully matched to the patient, or the therapy must be engineered from the beginning to avoid the need for matching. And both of these approaches are being explored by developers. Because my experience leading a collection team that supported healthy donor material for allogeneic cell therapy developers, my perspective and expertise leans heavily towards these engineered allogeneic cell therapies. And this is really where the Leukopak Lady series is going to focus. I purposely left out in vivo CAR T therapies as a category. I view this approach to be more like a vaccine than a cell therapy because there's no cells that are collected and manipulated ex vivo. Nevertheless, these are promising therapies and they should definitely be on our radar. So please join me for the next episode of the Leukopak Lady, where I'll talk about the different types of cellular starting materials used to make these engineered allogeneic cell therapies.